All right, so today we're going to review the factoring of polynomials, and then we're going to expand that to some more patterns. Okay, so when you are factoring, we have to remember how to take out the GCF. So you should have taken out 2, an A, and a B. When you take out the GCF, remember how that sits in front, and then your parentheses go behind it. And then once you factor that out, what were you left with inside?
A cubed B squared.
A cubed B squared, and then here you have plus 3. Okay? Now with your difference of 2 squares, you have to take the square root. So you have 2x plus 3y and 2x minus 3y. All right, and remember we can always FOIL it back and check. When you have the difference of 2 squares, the inside and the outside terms will cancel. In this case, it's negative 6xy and positive 6xy. Okay, but you can find those by taking the square root of each if you have the difference of 2 squares. All right, we worked a lot with the perfect square trinomials. Okay, so the square root of 49a squared is 7a. The square root of 16 is 4. Your sign is going to match whatever sign you have here. And then you can also check it because 7 times 4 is 28. If you double that, it will equal the middle number. Same thing with this one. You take the square root of 25b squared, you get 5b. Square root of 81 is 9. Symbol matches the inside. And then 9 times 5 is 45. If you double it, you get 90. All right. And then for the last two, you guys did guess and check with FOIL. So you have to start with x and x, what multiplies to negative 18 but adds to negative 7. Negative 9, positive 2. You can write those in any order. And then did you guys have time to do the last one, or did you need another minute to finish that? Okay, so you have to start it with what and what?
3y and y.
3y and y, because it's a prime value. Okay, so 3y times y, and then it has to be something that multiplies to 20. So your options are 1 and 20, 2 and 10, 4 and 5. And then notice that you have a positive and a negative. What does that tell you about the sign? They're both going to be negative. Okay, so if we plug in like 5 and 4, what would that be? Negative 19? Negative 2, negative 10. Let's see what we get. And remember, you can always check those with the FOIL. So you have the negative 2y. 3 times negative 10 is negative 30y. Great. Okay, so today we're going to extend our skills to learn how to factoring by grouping, which some of you have already done this before. You guys have already factored with 4 terms. Some of you, maybe. I feel like I've seen several people throughout today that have done this, so you guys can let me know. You can actually use this technique with 4 or 6 terms. We're mainly going to be using it with 4 terms. Okay, and this is called grouping. So you want to make sure the equation is in standard form. So that means you have the highest exponent and then goes from greatest to least. We're going to group the first 2 terms and the last 2 terms together using parentheses. We're going to group these 2, we're going to group these 2. You always want to factor out the GCF. The GCF is going to be a common monomial. So that means it consists of numbers and letters, variables. And then we're going to use the distributive property to rewrite the expression. Now, sometimes people can get a little confused at this step, so we're going to go over that when we get there. And you need to have the same factor inside your parentheses. Okay, if it's not the same, you cannot factor by grouping. Okay, if it's not the same, okay, then you can't use this technique. They're not the same, you cannot. Factor by grouping. So this is the factoring by grouping method. Okay, and just like we did before, we really do always want to check to make sure there's not a GCF with all of them. Sometimes there will be a GCF that you can take out of everything. Okay, so you can always do that at the beginning. And then when you're using your parentheses, we're going to group the first two together and then the last two together. Okay, so then we say, all right, between x cubed and x squared, I can take out an x squared. If I take out an x squared, I'm dividing. So x cubed divided by x squared is x. Negative x squared divided by x squared is negative 1. Then, with this set, I have a negative 25x. I want this to be x minus 1, so I'm going to take out a negative 25 here so that I'm left with x minus 1. Now, you can always check that with the distributive property. Negative 25 times x is negative 25x. Negative 25 times negative 1 is positive 25. And then this is the step where you're going to use the distributive property. So whatever is on the outside, this becomes one factor, x squared minus 25. The other factor is x minus 1. Okay, you do not have to write this part down, but I want to show you how that works, because usually students are like, but we had 2 and now we have 1. So what we're doing is we're rewriting this. Remember in the last chapter when we were multiplying how we had to do distribution? If you were to distribute the x squared to x minus 1, you would have this. And if you were to distribute negative 25 to x minus 1, you would have this. See how this is exactly the step that we have here? So this is what we're doing. We're rewriting it with distribution. Okay, so these two mean the exact same thing. Okay, we're just organizing them differently now. And then you always want to check. Okay, sometimes people forget to pull the GCF out at the first step because they like to group right away. That's fine. Just make sure once you're here, you check for patterns and your GCF. Okay, so I don't see a GCF. Do we see any special patterns here? Yeah, what do we see there? Well, we're here. Oh, here.
Oh.
Looking for some special patterns. What's special? Yeah, you have the difference of two squares, right? Isn't 25 a perfect square? Can we break this down into x plus 5 times x minus 5? Good job. So your difference of squares right there. Got to break it down. So this is your final answer. All right, I want you to try to do B. You guys did a nice job starting this and pulling out the x squared. And then when you pull out a positive 4, I put the plus there. So you know what you're going to be adding. And then again, you get the 2x plus 1. Okay, so when you make your two factors, you have x squared plus 4 times 2x plus 1. Okay, now sometimes we try to break this down. 4 is a perfect square. You can't factor the sum of two squares. So don't be too hard on yourself if you did. Okay, I know several of us did. Okay, I anticipated that. That's a common mistake. You can't factor the sum of two squares because if you try to factor it down into x plus 2 times x plus 2, if you were to FOIL that back, what would you get? There'd be a 4x in the middle, right? You would have x squared plus 4x plus 4. Okay, so you have the x squared plus 4, but you also have the 4x, so you can't break that down any further. This is going to be your final answer. Okay, so you are looking for the difference, but if you have the sum of the perfect square, remember it should FOIL back to what you have. Now, we are going to learn two new patterns, and they're about perfect cubes. Perfect cubes, there is a sum of cubes and a difference. Okay, the reason why it works with cubes is because you can take the cube root of a positive or a negative. So we're going to have some special patterns for that we're going to practice today. Okay? You ready? All right, so the sum and difference of two cubes. So if you are given two cubes, which we're calling a cubed plus b cubed, if you have the sum, it's going to be a plus b, and then it's a squared minus ab plus b squared. This is the factorization. Okay, and then I want you to look at those patterns and see what you have. All right, so if you have the sum of two cubes, notice how it starts. You have the plus in the middle. If it's the difference, you have the minus. What about the next signs? Yeah, so if it starts with a plus, it's a minus, it swaps. This one, minus and then plus, it's the opposite. What about the last one? It's always stays positive. It's because if you're squaring something, right, whether it's a negative times a negative or a positive times a positive, isn't it always going to be a plus? Okay, so that's why the last one is always going to be positive. Okay, so our reminders for these, again, which you're going to hear me say this a lot today, is you've got to take out that GCF first. You have to look for what they have in common. Sometimes people are like, oh, there's no special pattern here. I can't do that part. That's because you got to make sure that you have your GCF out so that you can see some of those special patterns. What's nice about these patterns is the trinomial, which here's your trinomial, here's your trinomial. Okay, that is not factorable. So you never have to try to break that down. It's a pattern, it's not going to be factorable. Okay, as long as you take the GCF out, there shouldn't be anything in common there. Okay, and you can't break it down. So in order to do this, we have to know what our perfect cubes are. We're really good at our perfect squares. Let's see if we can generate our perfect cubes together without a calculator. And then I'll tell you the harder ones, okay? So to find perfect cubes, you really just have to find that number to the power of, a number to the power of 3. Okay, so what's 1 to the third power? 1. Do we know 2 cubed? Do we know it? I know you know it. I want to see if other people know. Do we know 3 cubed? Good. Okay. Do we know 4 cubed? Yeah, good. Yeah, 16 times 4. Yeah. Okay, now 5 cubed, bless you, we should know. 5 cubed, we should know. 125. I don't expect you to know 6 cubed, but oh,
I know my perfect cube.
that's so great. Do you know 7? 343, yeah. So, and honestly, it's really okay if you don't know these because I want you to, you're going to use this as a reference. I know, that's so great. 729. Now 10 cubed we should know because it's just, yeah, 10 times 10 times 10. So you just have your 1 and then your 3 zeros. Okay, so you can use this list to help you, okay? All right, and then when we are factoring, we're going to use those special patterns. So what we want to do is we want to think, okay, we have a value to the power of 3 plus another value to the power of 3. So for this, y to the power of 3 is y cubed, and now we know what to the power of 3 is 512, 8. So we're going to plug that in. So when you're using your pattern, you're going to think of the a value as y, and you're going to think of the b value as 8. So when you plug this in, see how it's a plus b? We're going to do plus 8, yep. And then a squared is y squared. If we do y times 8, how do we write that? Yep. And then 8 times 8, 64. Okay, so then that's going to be your final answer. So how many of you have done perfect cube patterns before? All right, and then for B, again, we're thinking to ourselves, what to the third power is 125d cubed? What to the third power is 8? So will you fill those in? And then I want you to see if you can do your final answer there. And if you finish with that, you can go to part C a little early. That's the GCF. Don't do this last one though, because I'm going to change it. This one is, the last one is really it's a lot. So I'm going to give you a easy one. Okay. Okay, so in the first one, what to the power of 3 was 125d cubed? 5 what? 5d. Yep, so you got to have your variable with it. And then what to the third power for 8? What did you just put in there? 2. Okay, so then the start, 5d minus 2. Great. Now here, when you square it, remember, it's 5d times 5d. So what's that? 5 times 5, d times d, 25d squared. Okay, now here you have plus a times b. So, oh, and I was going to tell you too. For some of you, I know it helps for you guys to see, like, this is your a and this is your b. So you do 5d times 2 to get your 10d. And then 2 times 2 will be 4, and that's going to be your final answer. Okay, so how did that go? Do you remember to square the 5 at the front? Okay. Now for the next one, when you're looking for your GCF, we know they're both even. We know 2 goes into both. Let's see if 8 goes into 216 evenly. We'll practice doing it without our calculator. 8 goes into 21 how many times? 2. 8 goes into 56 how many times? 7. Okay, so 8 does go into both of them. So if we take out 8, we're going to be left with x cubed plus 27. And then do you see once we take that out, now we have the sum of 2 cubes. We have the cube here and the cube here. So I want you guys to follow the pattern. And then your GCF just lives in front there. Okay, so I want you to practice the pattern. I'll come around and check that, and then you can go to D. Okay, so when you apply your pattern, and then make sure you guys go to D afterwards. Okay, so when you guys are doing this, you're thinking, okay, what to the third power makes this? What to the third power makes this, okay? So the x to the third is x cubed, 3 to the third is 27. So make sure you guys started with x plus 3 and not x plus 27, okay? And then you're going to follow your pattern. So you're going to square the x. You're going to multiply x times 3, and this is minus. And then 3 squared is going to be 9. And this is your final answer. Okay, and then if you guys wanted to check you can multiply this back. When you distribute the x and you distribute the 3, and then you have that polynomial, you multiply the 8 back, and you should get the same thing there. All right, so you can always multiply and find that. All right, for D, what's your GCF? What could you take out of both? Yep, the 4 and the x. So once you do that, now you have x cubed. Okay, when you do 108 divided by 4, 4 goes into 10 how many times? 2. So we're going to bring this down. 4 goes into 28. And then look, see how this is the same thing that we had before? The exact same thing. So this is still going to be x plus 3, x squared minus 3x plus 9. All right, and then we're gonna start example 3. So what I want you guys to do for part A is I want you to take out the GCF. And part B, I'm gonna show you how to do this, but like I said, I'm gonna give you a little bit of an easier one. All right, so take out your GCF. Sorry. All right, so once you take out your GCF, now we're going to have to factor, and this is a trinomial. Okay, so we're going to have to do some guessing and checking here. So again, GCF should always be what you go to first. What do they have in common? So you're going to take out 4a squared. Okay, so you'll be left with a to the 4th minus 4a squared. And then you guys worked with 180 a lot last year, right? If you're dividing it by 4, you can cut it in half twice. Because we know half of 180 is 90. Half of 90 is, yeah. Because you guys were dealing with all those angles last year, right? Now, when you try to factor it again, you have your 2 parentheses. A to the 4th is going to be split up into a squared and a squared. And whatever you have in the front is just going to live there. Just lives right in the front. Drop it right down. Okay? We aren't even going to look at that anymore because we want to break this down. Okay? We're unfoiling. So we're looking for 2 numbers that multiply to negative 45 and have to add up to negative 4. So for this one, you probably guess it right away, but remember you can always use your factor table to write down all the factors and see which 2 would give you negative 4, which of course would be, okay, so your 9 is going to be negative, your 5 is going to be positive, doesn't matter what order you put them in. And then just like we did previously, you're always checking. Okay, make sure that you're checking for those special patterns. Sometimes they happen, sometimes they don't, but we do have one here. Which one is the special pattern? The difference of 2 squares? Yep, which one? Which one is the perfect square? Yep, the 9, okay? So this is going to break down. So we're going to have 4a squared plus 5. 5 isn't a perfect square, so we can't break that down. A plus 3, a minus 3. Nice work. So then this is going to be our final answer here. We have the GCF, a squared plus 5, and then this is going to break down. All right, and then, like I said, the original B that I gave you is kind of cray, and I will show you what that is. But we're going to do this one. It's a little bit easier. Okay? So for part B, again, I want you to take out your GCF. So the GCF is going to be what? 2. The only thing that goes into 2 is 2, and we know that that's even. So when you're cutting something in half like this, you don't need your calculator. What's half of 1,000? 500. Yep, half of 24 is 12. So 512 minus y to the 6. Now this one is a little bit different. because we have y to the 6th. That's okay. Remember, you are always thinking to yourself, what to the power of 3 is this value? What to the power of 3 is this value? Okay, so I want you to plug in what you think those are. Okay, so what to the power of 3 is 512. What to the power of 3 is going to be y to the 6th. And then our 2 is going to live in front here. I'm just prepping this for our final answer. Okay, so using our perfect square table, we know that what to the power of 3 is 512? 8. Okay, and then from our exponent rules, we know y to what power is going to be, yeah, so y squared to the 3rd, 2 times 3 is 6. So now when we're using our pattern, our a value is 8, our b value is y squared. Sometimes we don't like that when the number is first, but that's how they gave it to us, so that's how we're going to plug it into your pattern. So when you do that, you have a minus b. So it's 8 minus y squared. Then you have a squared. Well, that's just going to be 8 times 8, which is 64. Then you multiply 8 and y squared. So 8y squared. And then you multiply y squared by y squared, which is going to be what? Y to the 4th power. Good. Okay. So this is going to be your final answer. All right. Now, like I said, right, I'm going to show you how to do that one and why I decided to change it. Okay. So for the 128, you would still take out the 2 and see how you have 64 minus y to the 6th there. Are you done writing this part? Okay. If you had that, then you would have 64 minus y to the 6th, which is the difference of 2 squares. So you could break that down into 8 minus y cubed and 8 plus y cubed. Well, what's this pattern? This would be what?
Perfect cubes.
Yeah, this is the difference of cubes, and this is the sum of cubes. So if you were to break that down, this guy, you would have, what's the cube root of 8?
2.
So you'd have 2 minus y, and then 2 squared is 4, and then you'd have plus 2 times y plus y squared. This 2 that's here would still live in front, and then this we would have to break down as well. And if we broke that down, you'd have 2 plus y. I know, it's not that bad when you break it down, but that is a lot to see, right? Yeah, so you're not incapable of doing it. I just thought it was a lot for this, okay? All right, so your homework tonight is a worksheet. It is mandatory. It is to a Google Classroom at 7:40 a.m. And I'm giving you the rest of the hour to work on this.